of current. So this is a new chapter we will start today. This is the magnetic effects of current. So the first derivation we need to discuss, that is Biot-Savart law. First we need to start the derivation of Biot-Savart's law. This is the first derivation we are going to discuss. So there is a one wire, there is a one conductor on the magnetic field. There is a one conductor. There is a conductor, there is a wire. We can say this is X, this is Y. And a current is flowing from that wire. A current is flowing from that wire, and the magnetic field is produced at point P. There is a magnetic field produced at point P, and that magnetic field produced, so we have chosen a small element that is called dl. This is the length of the conductor. This is a length of the conductor L. We have chosen a small element. That small element length is dl, and there is a magnetic field produced due to the current flowing from the wire, that is dB at point P, and the distance from that point to P is r, and the angle made from the magnet where the magnetic field is produced, that is theta. So this is the diagram of Biot-Savart law. So what is Biot-Savart law basically told us? The magnetic field that produced at point P, it is directly proportional to current I. The magnetic field produced at point P, it is directly proportional to current I. It is directly proportional to current I. And the second point is the magnetic field is produced at point P is proportional to the small element dl along the length of the conductor. And the third point is the angle, this theta. This theta is the angle is the magnetic field produced at point P. From this angle theta, dP is directly proportional to sine theta. And the fourth part is this magnetic field produced, it is inversely proportional to 1 by r square. It is inversely proportional to 1 by r square. So we have, combining all these 4 points, I dl sine theta divided by r square. So we are removing the directly proportional. It is equal to k I dl sine theta upon r square. This k is constant term we have taken. What is the value of k? That is mu 0 upon 4 pi. Mu 0 upon 4 pi equals to 10 raised to the power minus 7 Tesla. This is Tesla milli per ampere, or we can say Weber per meter per ampere. This is the derivation of Biot-Savart law. And what is mu 0? Mu 0 is permeability of free space. This is the permeability of free space. So dB equals to mu 0 IDL sine theta upon r square. So we can write this equation according to vector form. So what is in the vector form? We have write down mu 0 I upon 4 pi. We have changed this k into mu 0 upon 4 pi I. This is dl vector multiply r vector upon r cube. dl cross r vector divided by r cube. So this is the derivation of Biot's law. If we approach theta equals to 0, so sine theta is also will be 0 because sine 0 is 0. If sine 0 is 0, the whole equation will be 0. The magnetic field will be 0 at all points on the axis of current element. If theta we have taken 90 degree, then sine theta will be 1. The magnetic field will be maximum. It will become maximum due to current element and perpendicular to the axis. Maximum at perpendicular because theta is 90 degree. So this is the derivation of Biot's law. I am going to repeat again. The magnetic field produced along the length of the wire, it is directly proportional to the current of the conductor, and the magnetic field produced, it is directly proportional along the length of the conductor, and it is directly proportional to sine theta, and it is inversely proportional to r square. So it is combining all the 4 points of this equation. We got dB is directly proportional to IDL sine theta upon r square. We remove the directly proportional point and we approach with k. So what is k? It is a constant term. So k is mu 0 upon 4 pi. This is the value of k, and the value is 10 raised to power minus 7 Tesla milliampere or Weber per meter per ampere. What is mu 0? It is permeability of free space. What is mu 0? It is permeability of free space. Then we have written the equation in the vector form. So after approaching theta equals to 0, we got sine theta is 0. Then we done magnetic field is also 0. If we approach theta equals to 90 degree, then sine theta will be 1, and the magnetic field produced, it will be maximum along the length of the wire of the conductor. So we have to compare Biot's law and Coulomb's law. What is Biot's law? Where's Coulomb's law? This is Biot's law, this is Coulomb's law. What is the formula of Coulomb's law? We have discussed in the first unit. The electric field produced 1 by 4 pi epsilon 0. Epsilon 0 is permeability of free space. dq upon r square. This is the Coulomb law. Electric field produced due to the charged element. And the Biot's law is magnetic field is produced. In the Coulomb's law, electric field is produced. In the Biot's law, it is a magnetic field produced. And the magnetic field produced mu 0.4 pi IDL sine theta upon r square. IDL sine theta upon r square. This is the formula of, this is the difference between Biot's law and Coulomb's law. Now the second derivation we are going to discuss. Magnetic field due to a long straight current carrying conductor. So magnetic field produced due to a long straight current carrying conductor. So this is a straight wire. This is a straight conductor. I have taken the point XY and the current is flowing from that wire, and the current is flowing from that wire. We have taken again a small element that is called DI current, and the point P here, the magnetic field is produced from point O. This is the magnetic field produced from point O, and this is the distance A. This is the distance. Again, we have joined the point Y to P, and the point P is here. So there is a point, join point P to the X, and there is a point where the magnetic field is produced, that is phi, and there is a point where magnetic field is produced phi 1. There is a magnetic field produced, that is phi 2. This is the distance A from that Q point. So this is the whole diagram, and this is the length of the conductor. This is the length of the conductor. So we have taken a straight wire where the current is flowing from the point X and Y. This current is flowing from the point X and Y. We have chosen a small element that is called DI. The magnetic field is produced at point P, and we are joining the point P from P to Y, P to X, P to Q, P to O. We have joining the 4 points, and this is the magnetic field is magnetic flux angle phi is produced. The phi 1 is produced from point X to Q, and phi 2 is produced here. So this is the diagram we have discussed. Now we are applying the Biot law. So what is Biot law? Formula is dB equals to mu 0 upon 4 pi IDL sine theta upon r square. IDL sine theta upon r square. So from the right triangle OQP, this is the right triangle OQP, this is the 90 degree, this is phi, this is theta. So this is the triangle OQP we have chosen. So what is theta plus phi equals to 90 degree, and what is theta? That is 90 minus phi. So first we have chosen the Biot law. This is the first step. Then we have taken the triangle OQP, that is 90 degree. Theta plus phi is 90 degree. Theta is 90 minus 5. So we have sine theta in the left hand side. We have taken sine 90 minus phi. Sine 90 minus theta, that is the first quadrant. Sine 90 minus theta is the first quadrant, and there is 90. So sine changes into cos 5. So what is cos 5? That is base upon hypotenuse. So what is cos 5? What is base? This is A. What is hypotenuse? That is R. That is R is the distance. So what is R? We can take R as A divided by cos 5. What is the reciprocal of cos 5? A. Secant 5. So what is tan phi? Again we have taken perpendicular divided by base. This is perpendicular, this is base. We have taken only from one triangle. What is L? L equals to A tan 5. This is the cross multiply. So on differentiating, now we are going to derivative. Differentiate with respect to phi. Differentiate with respect to 5. L changes to dl. A is a constant term. The derivative of tan is secant square 5, and the phi is d phi. So we have put this dl value here. So what is db? Mu 0 upon 4 pi I. What is dl? A secant square phi d phi. What is sine theta? Sine theta is cos 5. Sine theta is cos 5. So we have taken along the we have put the value of sine theta, that is cos 5. And what is the value of r? What is the value of r? We have taken r is a secant square 5, that is r square, so it is a square secant square 5. This is we have put here. We have cancelled out one a, we have cancelled out secant square 5. What is db? Mu 0 upon 4 pi I, that is cos 5 d5. After cancelling out, we have got mu 0 I upon 4 pi a cos 5 d5. So this is a small amount of magnetic field. If I want to calculate the total magnetic field, what we need to do? We need to do the integrate of magnetic field from the interval minus 5 1 to 5 2, that is dB. So what is dB? Mu 0 I upon 4 pi a minus 5 1 to 5 2 and cos 5 d5. We need to integrate. This is the constant term, so we have taken outside, and the integrate we will do from the of the cos 5. So mu 0 I upon 4 pi a, what is the integral of cos 5? That is sine 5 from the interval minus 5 1 to 5 2. So mu 0 I upon 4 pi a, so this will be sine 5 2 minus sine minus 5 1. So after solving minus minus plus, mu 0 I upon 4 pi a sine 5 1 plus sine 5 2. Okay, so this is the derivation of magnetic field from strong long length conductor, long wire conductor. So this is the derivation. If we approach 5 1, this is the cases. Now we approach if 5 1 and 5 2 will be 90 degree or pi by 2. So what is the magnetic field here? This is sine 90, this is sine 90. It will becomes 1. So 1 plus 1 will be 2. 2 cancel out with 4. Mu 0 I upon 4 pi a sine 90 is 1. Sine 90 is 1. Mu 0 I upon 4 pi a. This is 2. 2 cancel out with 4. So mu 0 I upon 2 pi a. So this is the derivation if we choose on the perpendicular 5 1 and 5 2 is 90 degree near the middle of the conductor. If the conductor x phi is infinitely long but the point P lies near the y, this is the case of middle point. This is the case of middle point if P is on the middle point. If P lies on near the x, near the y, near the y conductor. So one will be 90 degree, mu 0 I upon 4 pi a. So one will be sine 90 degree, other will be sine 0. So sine 0 will be 0, sine 90 is 1. So the answer will be mu 0 I upon 4 pi a along the near of y of the conductor. So this is the derivation of magnetic field along the long straight conductor. Along the long straight conductor. So the next derivation we're going to discuss. First we need to revise the whole part. So we have taken the long straight wire XY where the current I is flowing and the point P where the magnetic field is produced. Point P where the magnetic field is produced in the middle of the conductor from the point O, and join the point P to the Q, and the angle will made 5 1 and 5 2. We have joined P to X and Y, and the point P to Q is the distance is A, and from point P to Y is the distance is R, and phi 1 and phi 2 there are two angles where the magnetic field is produced along X and Y. So we have chosen the Biot law. B is equals to mu 0 upon 4 pi IDL sine theta upon R square. And then we have taken the triangle, right triangle OQP. Theta plus phi is 90 degree and theta is the 90 minus phi. So along the left and right hand side, we have chosen sine theta, sine 90 minus 5. Sine 90 minus 5 is cos 5. What is cos 5? That is based upon hypotenuse. Base is A, hypotenuse is R. What is R? A upon cos 5. So 1 upon cos 5, the reciprocal will be secant 5. So how to calculate the tan 5? That will be perpendicular upon base. The perpendicular is L, base is A, so the L is A tan 5. We have differentiate the L. dl equals to A secant square phi dy. A is constant term. The derivative of tan is secant square phi, then d phi. We have put the value of dl in the Biot law. We have put the value of sine theta. We have put the value of r. After putting the value, we got mu 0 I upon 4 pi a cos 5 d 5. So we need to calculate the total magnetic field from the interval minus phi 1 to phi 2. So we put the value of dB, and the constant part will be outside from the integral, and the near part is cos 5. We have integrate the cos 5, it will become sine 5 minus phi 1 to phi 2, sine phi 2 minus sine phi 1. So after solving, we got the results. So the next derivation is magnetic field at the center of circular carrying loop. Now the third derivation we're going to discuss, magnetic field at the center of circular current loop. Center of circular current loop. This is a circular current loop and the current I is flowing, and the current I is flowing from the circular current loop wire. So we need to calculate the magnetic field at the center O. This is the magnetic field where the center O magnetic field is produced at the point O. So this is the small length of the conductor. This is the small length of the conductor, and from here we have radius R, and here the magnetic field is produced. So the current is flowing from the circular wire, and the magnetic field is produced at the point center point. There is a small length of the conductor dl. From the magnetic field at O and along the length of the conductor, the distance is r. So we know the equation of Biot law. So the Biot law is dB equals to mu 0 upon 4 pi IDL I. This is the vector form, dl cross r upon r cube. So this is the 90 degree along the center of the circular wire. It is perpendicular. So we have taken mu 0. What is dl into r? dl sine theta. dl r sine theta. This is a cross product. Due to cross product, we have taken a sine theta. So this is mu 0 upon 4 pi I dl r sine theta upon r cube. It is cancel out, it is r square. Mu 0 I upon 4 pi, this is 4 pi dl sine theta upon r square. So this is a 90 degree because it is in the middle of the circular wire which I have made a 90 degree from the radius r. So this is a dl sine 90 degree upon r square mu 0 upon 4 pi I. Sine 90 is 1, so it is dl upon r square. So we need to calculate the total magnetic field. We need to calculate the total magnetic field. We have to integrate this part to calculate the total magnetic field. Mu 0 I upon 4 pi dl upon r square. We are going to integrate. This whole part is constant term, so we have taken the outside from the integral 4 pi r. We have integrated the dl. What is the circumference of the circle is 2 pi r mu 0 I upon 4 pi r square. So dl is 2 pi r. So the answer is r will be cancelled out, 2 is cancelled out, pi is cancelled out. The equation is mu 0 I upon 2r. This is the total magnetic field of the circular wire. So if I say this is not a one turn, there are number of turns. There are number of turns of a circular wire. So we have taken B equals to mu 0 upon Ni 2r for the case of number of turns of a circular wire. So this is the derivation of circular wire and magnetic field is produced. So we have done two derivations. It is a long straight wire and then circular wire. These are the two derivations how the magnetic field produced in the long straight wire in the middle of the conductor, and in the circular wire it is along the center of the point of the conductor and the magnetic field is produced. So now the next is magnetic field along the axis of circular current carrying loop. Now we are going to discuss the third derivation, magnetic field along the axis of circular current loop. So this is a circular wire where the current is flowing along the length of the conductor, This is the middle point O. And the magnetic field is produced at point P here along the x-axis. This is the magnetic field produced, and from that point the distance is s and the distance is x here from the center point O. The magnetic field were produced and the angle made from this is phi. So the magnetic field is produced along the x-axis, that is dbx in the vector form, and along this it is db perpendicular magnetic field. This is the perpendicular magnetic field. This is db magnetic field from where the angle is produced, and this is we have made a parallelogram law. So this is the diagram we have made from along the axis of circular current carrying loop. Again we start with Biot law. What is Biot law? dB mu 0 upon 4 pi I dl sin theta upon s square. And theta here is 90 degree because this is perpendicular form. Magnetic field is produced, it is perpendicular. This is magnetic field, this is the 90 degree, this is the 90 degree. So dB equals to mu 0 upon 4 pi I dl upon s square, I dl upon s square. So along the axis of the direction, along the axis of the direction, we have chosen, along the axis of the direction, we have chosen the magnetic field, total magnetic field. How to calculate the total magnetic field? Integrate the small amount of magnetic field along with sine phi, along the axis of the current. So we have taken dB sine phi. What is sine phi? Perpendicular upon hypotenuse. Perpendicular is A, this is A, hypotenuse is S. So we have put the value here. dB is mu 0 upon 4 pi I dl upon S square A upon S. So it becomes mu 0 IA upon 4 pi S cube, and change the small amount of current dl. What is the circumference of the circle? That is 2 pi a, 2 pi a, 4 pi s cube. It becomes 2 pi a, pi is cancel out, 2 is cancel out, so it become mu 0 I a square upon 2 s cube. What is s? We have taken a Pythagoras theorem. So h square equals to p square plus b square, mu 0 I a square to r square plus a square, r square plus a square 3 by 2. So this is the Pythagoras theorem we have taken from that. S square equals to r square plus a square. Okay, so after integrating we get this value. Now we are doing the write in vector form, mu 0 I a square upon 2 r square plus a square, that is 3 by 2. If there are number of terms, so we have taken b0, b vector equals to mu 0 n I a square r square plus a square 3 by 2, that is 2. At the center of the loop, if the first case is at the center of loop, at the center of loop, r is 0. So we have put r0 here. The answer will be mu 0 n I a upon 2 pi a cube. At the axis of the loop, at the axial point of loop, far away from coil, far away from coil. So r is greater than a, so reject is a. So we have answer mu 0 n I a square upon 2 r cube. Okay, so these are the cases we have discussed along the axis of circular carrying and the axis of circular carrying current loop. So we have done 3 derivations today along the long length of the conductor, circular current carrying loop, along the axis of circular coil. So I hope you understand the whole part. So we discuss the next part later. So these are the 3 derivations. If you like this, please subscribe and share this video.